Hello, my name is Bei Lee, and this presentation introduces my final project for CSCI E222, RAG for Domain-Specific Question Answering in the Legal Domain. The motivation is practical. Legal documents are long, technical, and very sensitive to wording. A general-purpose answer that sounds fluent is not enough. In contract review, the user usually needs to know what the agreement actually says and where the supporting language appears. My project builds a lightweight retrieval-augmented generation workflow that can retrieve legal evidence from contracts and produce a short, grounded answer. I focus on a reproducible setup that can run at laptop scale, so the project is not only a concept, but also a working software example with data, metrics, visualizations, and qualitative outputs. The central problem in that legal question answering needs evidence, not confident, unsupported summaries. A contract review question may ask whether there is an insurance requirement, an audit right, a termination clause, or a revenue sharing obligation. These questions often refer to a clause concept rather than quoting exact language from the document. That makes retrieval difficult. If the system retrieves the wrong passage, the answer stage will either miss the answer or produce something misleading. In the example on this slide, a weak answer might generalize about insurance clauses, while a grounded answer points back to the selected contract text. The project question is therefore, can a lightweight RAG pipeline retrieve the right CUAD passage and produce a short, grounded answer that is useful for legal review? For data, I use QAD, the Contract Understanding Atticus dataset. QAD contains 510 commercial contracts and more than 13,000 expert annotations across 41 legal clause categories. To keep the project reproducible and easy to run, I use the first 80 contracts as a laptop-scale subset. This produces 4,731 overlapping retrieval chunks and 1,015 answerable question-answer pairs, before sampling 240 evaluation questions. The pre-processing is intentionally simple. I load the squad-style JSON, select the contract text, and split each document into 1,200-character windows with 200-character overlap. This chunking choice tries to balance two needs: preserving enough legal context around a clause, while keeping retrieval fast enough for repeated experiments. The workflow has 5 main stages. First, the notebook loads CUAD contracts and annotated answer spans. Second, it creates overlapping text chunks. Third, it vectorizes those chunks using either TF-IDF or a mini-LM sentence transformer. Fourth, it retrieves the top candidate passages. Finally, it generates a grounded answer by selecting evidence sentences from the retrieved text. The important experimental variable is retrieval scope. In the global setting, the retriever searches across many contracts at once. In the contract scope setting, retrieval is limited to the selected contract. That scope switch is very important because it matches the real legal review workflow. A reviewer is usually asking about one contract at a time, even if the clause category is common across many contracts. This table separates model choice from retrieval scope. I compare a lexical TF-IDF retriever and a dense mini-LM retriever under both global and contract-scoped retrieval. The metrics are recall at 1, 3, and 5, MRR at 5, and a top 1 same document rate. The global results are very low. TF-IDF Global reaches only 7.1% recall at 5, and mini-LM Global reaches 5.4%. Once retrieval is scoped to the correct contract, performance changes dramatically. TF-IDF scoped reaches 37.1% recall at 1 and 65.4% recall at 5. Mini-LM scoped is also much better than global, reaching 57.9% recall at 5. The best practical setup in this experiment is TF-IDF with contract scoped retrieval. The chart makes the main result easier to see. Contract scope moved recall at 5 from single digits to 65.4% for the TF-IDF retriever. This matters because it suggests the biggest gain did not come from replacing a sparse retriever with a denser model. The biggest gain came from defining the legal search boundary correctly. Global search failed because many QAD questions name a clause type, such as insurance or governing law, but do not provide enough unique detail to distinguish one contract from another. In that setting, semantically similar clauses from unrelated contracts can outrank the true evidence. Once the retriever searches only the selected contract, the task becomes much more realistic and much more reliable. One technical lesson is that exact wording can beat semantic breadth in this legal subset. TF-IDF worked well because legal contracts contain repeated terms, defined phrases, and clause headings. Phrases such as agreement date, insurance, license grant, and revenue sharing often carry strong lexical signal. The evaluation also rewards exact evidence recovery, so retrieving the right legal language matters more than producing a broad semantic match. Dense retrieval is still useful, but in a global setting it can drift toward a passage that sounds conceptually similar while belonging to the wrong document. For this project, the lesson is scope first and model second. A stronger model cannot fully compensate for a poorly defined retrieval boundary. This slide shows a qualitative example about insurance. The question asks whether there is a requirement for insurance maintained by one party for the benefit of the counterparty. The gold span says that each party must maintain adequate insurance during the term, including product's liability coverage and other relevant coverage. The generated grounded answer includes the retrieved legal sentence and surrounding context. It is not trying to act like a lawyer or invent a conclusion. It is extracting the relevant evidence so a reviewer can inspect the source. Across the evaluation questions, the selected evidence sentence contained the exact gold span 29.2% of the time. That is a strict metric, because a useful paraphrase or partially relevant passage still does not receive credit unless it contains the exact annotated span. The demo is instructive, but it is not a legal product. There are several limitations and risks. First, the dataset scope is small. 80 contracts make the experiment manageable, but they do not represent the full diversity of commercial agreements. Second, exact span containment is useful for evaluation, but it undercounts paraphrases and does not fully measure groundedness or citation precision. Third, the answer is deliberately extractive, so it copies evidence rather than making a legal judgment. A production system would need confidence scores, abstention behavior, highlighted citations, privacy controls for uploaded contracts, and review by qualified professionals. The responsible use bottom line is that legal RAG should support evidence retrieval and review. It should not replace legal judgment. The next version should improve retrieval, measurement, and citation user experience. I would start with a legal re-ranker, such as a cross-encoder re-ranking stage, so the system can rescore candidate clauses after initial retrieval. I would also add category-level evaluation, because some clause concepts are easier than others, and a single aggregate score hides those differences. For measurement, I would move beyond strict exact span containment and add groundedness and citation precision checks. Finally, I would build a contract review interface where the user can upload a contract, ask a question, inspect highlighted evidence, and see confidence or abstention signals. To close, this project demonstrates that a small, reproducible RAG pipeline can reveal a core design principle for legal QA. Retrieval scope and evidence visibility matter as much as the model choice.